So, toxicology. What is toxicology? Toxicology is the study of poisons, toxins, and drugs and the effects that it has on a person. So that's exactly what toxicologists study. They're looking for the source of the exposure and the effect it has on the body. And then they research and develop techniques and treatments to detect those substances within the body. This toxicology is not the researching of cures for these poisons, it's simply how to detect them within the body. Okay, so where are toxins found? This is very common knowledge. It's not just in the cyanide pill, it's not just in, radioactive material like uranium. Those do cause harm, but they're in much more common items that you find in your house. So some prescription and over-the-counter drugs can be dangerous. Gasoline, common sense. You don't drink gasoline. That would not be good. Alcohol, not the fun kind, the kind that cleans wounds. You do not drink that because that would not be good for you and it would hurt. Pesticides, pesticides are fertilizer, right? You're not going to put Scott's, weed and feed as a crouton in your salad. You're not going to eat that. You're not going to spray Roundup. That's not going to be your dressing in your salad either. Lots of salad analogies. You're not going to put this stuff in your salad. And cosmetics, ladies, don't go licking your foundation. I wouldn't put your eyeliner in your apple juice in the morning. It wouldn't taste good and would probably damage your internal body. That's how it happens. And I was talking a lot about eating and drinking, but that's ingestion, right? You can get toxins in your body and in your anatomical system in other ways, right? Inhalation, you breathe stuff in. If you breathe the toxin in, that's also not good. Injection and absorption, that's through the skin, through touch. The seriousness of these toxins depends on a lot of factors. So how big the dose was, how long was it in your system, the nature of the exposure. So drinking something could be worse than inhaling something, right? So how you took it in can also impact the effect it has on you. A common thing toxicologists see is the interaction with alcohol and drugs within the body. They react with each other and they can create byproducts and it can be really dangerous. So, not toxicology, but poisons have been used throughout history. The first recorded case of the use of poison was Socrates. He was poisoned with hemlock in 399 BC, so 400 years before the birth of Christ. There's a very interesting quote from Paracelsus, who was a 16th century alchemist. He once said that all substances are poisons. There's none which is not a poison. The right dose differentiates a poison and a remedy. So, in other words, anything in excess is bad for you. It wasn't until 1600 that it became widely used by aristocrats to poison their enemies. In fact, arsenic was used so widely that it became known as inheritance powder, which is so cool and awesome. It wasn't until the 1800s that substances were detectable. This was because of the work of popular physician Matthew Orfila, who was born in 1787, Robert Christensen. They both developed the first chemical analysis methods to detect these substances. And in 1855, Carl Mohr, along with his buddy Carl Frencius, pioneered improvements in qualitative analytical chemistry. Then came along Charles Norris and Alexander Gettler, who transformed investigative science of death by developing standardized techniques and testing to help determine causes of death. Way in the future, the FDA was created in 1959 to protect society from harmful food, drugs, and cosmetics. America capped it off with the Controlled Substances Act, which established penalties for possession, use, and distribution of illegal drugs. Nowadays, poison is extremely rare. It's really only used in assassinations, like Kim Jong-un's brother, who died in an airport. It was really cool. So now, investigation of cases of drugs and poisons are handled extremely carefully. So as we learn in forensics, the proper records are necessary, photographs, and the really detailed collection of any evidence pertaining to the drugs is essential because any of this can be presented in court. Evidence in drug cases can include pills, powders, liquids, shrooms, botanical stuff like that, shrooms and leaves, crystals, if you're dealing with meth, and other pieces of evidence can be found on articles of clothing or even wet fabrics. Apparently, drugs can still be found on that. And biological evidence of suspects is also important in these cases, which can include blood, saliva, sweat, or urine. And careful packaging of evidence is vital to the preservation of this evidence because it's so delicate. So any plant matter like marijuana or any wet articles like blood-stained clothing, they have to be dried and placed in paper, not plastic bags, in order to prevent mold and contamination and a bunch of other stuff. That's it.
Within toxicology, there are various ways of testing a substance. The factor determining the kind of toxicological test used is based on the quantity of the substance left from evidence collection. Scientists want to see how much of the substance they can work with before deciding the best method. It is the duty of a toxicologist to provide the following information when retrieving the substance: what the substance is, whether any properties of the substance are illegal, and the number of times he or she spots the substance. Toxicologists perform the most thorough testing upon arrival on a crime scene compared to that of first responding law enforcement officers. The first responders attempt testing the substances, but do not administer a firm, accurate identification of what the substance could be. The types of preliminary testing that first responders implement include colorimetric testing, microscopic testing, microcrystalline testing, and gas chromatography. Colorimetric testing accomplishes a color change in the substance in question. Microscopic testing is the analysis of a plant's elements. Microcrystalline testing is the process of placing a portion of the evidence in a solution to determine how it shapes under ultraviolet light. Data is taken from the substance's absorption of the light. Gas chromatography is the dismantling of a substance into its individual parts. This testing is used in preparation to the confirmatory testing performed by toxicologists. Toxicologists develop a conclusive identification of substances through confirmatory testing. This test helps toxicologists answer the question of whether a substance caused acute or chronic poisoning. Acute poisoning occurs with symptoms instantly after a high dose within a short span of time. An example of acute poisoning is the consumption or inhalation of cyanide. Chronic poisoning is the opposite. Symptoms are caught further down the road with chronic poisoning as the low dosage was taken over multiple and longer spans of time. Mercury and lead are two metals that contain concentrations that fluctuate toxicity levels in the body. These are examples of chronic poisoning. Other tests of determining acute or chronic poisoning include gas or liquid chromatography, mass spectrometry, capillary electrophoresis, and wet chemistry. Chromatography of a gas or liquid breaks down the samples of the substances into noticeably divided parts. Mass spectrometry turns molecules into ions. These ions split the substance apart through electric or magnetic fields. The data of the substance is later presented graphically. Capillary electrophoresis is the separation of ions by their charge. Wet chemistry dismantles compounds by utilizing liquid solvents. It is essential for any toxicologist to be aware of all the information and results from any testing he or she conducts when testifying in a court of law. The court looks for the type of test performed and the toxicologist's confidence level of these results. Heavy metals, such as arsenic, lead, and mercury, have been the leading causes to suicides, homicides, and accidental deaths. Heavy metals enter the body if eaten, breathed in, or absorbed through skin or mucous membranes. They can harm organs by existing in the soft tissues of the human body. Environmental exposure, like arsenic contaminating drinking water or mercury poisoning from industrial waste in the water, have been a factor to many deaths. Arsenic can be found as an element in groundwater that can produce acute poisoning with many excruciating symptoms: convulsions, kidney failure, delirium, and death. Arsenic can also induce chronic poisoning. Symptoms: skin lesions, headaches, personality changes, and possibly falling into a coma. Mercury is used as the coal-fired power plant pollutant and can be found in the fish that people eat. Acute symptoms of mercury include muscle aches and upset stomachs. Chronic symptoms that are found in the long run of consumed mercury include memory and balance issues, abdominal pain, nausea, damage to the gums, mouth, and teeth, and sometimes death. Lead poisoning derives from the ingredients found in gas, older paints, weights, and bullets. Symptoms of lead include nausea, abdominal pain, insomnia, anemia, seizures, blue discoloration on the gum line of the mouth, and sometimes death. In the present day, hydrogen cyanide is an element of seeds, nuts, and the smoke from a cigarette. Hydrogen cyanide has also been seen in the 1900s for punishing criminals for capital crimes in the U.S. Potassium chloride and sodium pentothal injections were also used to end the lives of criminals behind bars. The potassium chloride's purpose is to interfere with the heart's function to send electrical signals. Sodium pentothal diminishes the central nervous system slowly. Various murder cases can include injections as the cause of death, which may be overlooked for a natural death if evidence of an injection is not noticed. In scenarios like this, it is extremely important to have toxicologists on the scene to perform tests to determine the accurate cause of death and look for the actual killer responsible. Other various substances and chemicals, designated for alternative purposes, are used to end the life of another. Herbicides and pesticides are kinds of poisons that are commonly seen to causing death. Herbicides are chemicals that control the growth of weeds. Herbicides are considered to be of a larger concern due to the high concentration in the supply of water across the globe, typically from agricultural usage. Pesticides are chemicals that kill bugs and rodents. These poisons were created with the intent to kill if exposed to or swallowed. Humans can attract illness and even approach death if pesticides or herbicides enter the body. Once these poisons enter a body, they linger in the fatty tissue. Symptoms become more worrisome and lethal as the substance remains longer or near the body. Aldrin and dieldrin are examples of pesticides that can cause anxiety, seizures, rapid heartbeat, muscle weakness, coma, and even death. Glyphosate mixture is an example of an herbicide that can cause kidney malfunction, eye irritation, gastrointestinal issues, and even death. Petroleum is found in both pesticides and herbicides. This substance has elements that cause it to remain in the body for longer periods of time. Petroleum is a fat-soluble substance that lingers in fat-laden tissues, like the brain. Therefore, children are at greater risk for pesticide or herbicide poisoning because of their brains still being in the process of development compared to adults. This kind of exposure on children can interfere with their brain growth and function. Diseases such as autism and attention deficit disorder often occur in children whose brains are still in the critical periods of brain development when exposed to pesticides and herbicides for too long. A toxin is a naturally made substance by something that is living that can inflict illness or death for human beings. Toxicologists primarily focus on toxins that originate from plants or animals. For example, the venom from a rattlesnake can be a lethal toxin. Another example is the consumption, inhalation, or injection of ricin. Ricin comes from the waste products of castor oil manufacturing extracted from castor beans. It only takes a small amount of 500 micrograms for ricin to become dangerous for humans. Death is an automatic symptom within 6 to 8 hours of its entrance in the body. Ricin is a toxin that was used for 2 assassinations, one killing the target and the other failing. But overall, toxicologists do not see toxins implemented in criminal activity.
Most people use drugs for their intended purpose, which is to, heal ailments and, make you healthy and stuff and relieve pain and all that. But some people don't do that, and they use drugs instead to, just get high. That's what they do. And this costs a lot of money and a lot of lives. Actually, it cost around $600 billion on drug-related crimes, and over half the people in federal prisons are there for drug-related crimes. And I know what you're thinking. What's a drug-related crime? Well, I'm going to tell you. A drug-related crime is a crime that you commit on drugs or to get drugs. Or having drugs. So if you have crack cocaine and you sell it and use it, that's a drug-related crime. Or if you're on crack cocaine and then you go and you rob a Macy's, that's also a drug-related crime. 18% of prisoners in federal prisons have admitted that they committed crimes to get money for drugs. And in 1990, 6% of the 20,000 homicides committed were drug-related. Did you know that drugs are classified into different sections? You probably did know that. Whatever. The drug sections are illegal drugs. These are the drugs that are against the law and illegal. And these are not good. Also, there's controlled substances. These are drugs that are legal, but their medical use is very restricted. So you can use them, but you gotta get permission from a doctor, you know what I'm saying? Eventually, the Controlled Substances Act grouped drugs into different schedules. There are 5 schedules of drugs. These classifications start at Schedule 1, and that's when they have a really high abuse potential and they don't have medicinal uses or whatever. And then the list goes down until you get to Schedule 5. And that is like you're all good. The drugs aren't bad. Well, if they can be abused, but it's really rare, and they do have medicinal uses. Alright, so Schedule 1 drugs. These have very high abuse potential and no medical use. You don't want to get injections with these. These kind of drugs would include heroin, your LSD, and your bath salts. That's all of the Schedule 1 drugs. Schedule 2 drugs also have a high potential for abuse, so they can be abused fairly easily as well. And they can be used medically, but they're restricted. So if you want to use them for medical use, you're going to have to get a note from a doctor, or you can't really use them. The Schedule 2 drugs would be methadone, oxycodone, and your methamphetamine. That's your Schedule 2 drugs. Schedule 3. This kind of has a potential for abuse. Not as bad as Schedule 1 and 2. Schedule 1 and 2. These are accepted for medical use. Like if you use these for medicine, you'll be alright as long as you don't use too much. And this would be your barbiturates, your steroids, and your ketamine. That's your Schedule 3 drugs. Schedule 4. These don't have a very high potential of abuse, and they're pretty widely used for medical stuff. Like, you're pretty good. This is your Xanax, your Valium, and a lot of sleeping pills. A lot of people use sleeping pills, so these are they're okay. Then your Schedule 5, very, very low potential for abuse, and a lot of medical uses. Like, a lot of people, it's used widely for medical use. So if you use Schedule 5, you're good as long as you don't go crazy and take 17 of them. This is your Robitussin and your Tylenol. Thanks.
All right, boys. Now we're going to talk about stimulants, depressants, and narcotics. Now, they're all in the same category here because they are all drugs that alter the natural function of the brain. They can therefore affect people's feelings and actions profoundly. For the most part, stimulants intensify mental and physical functions like alertness and heart rate. Depressants, on the other hand, have a relaxing effect and might slow physical functions like breathing. Stimulants and depressants come in food components, prescription medicines, and illicit drugs. Like many other classes of drugs that affect the brain, many stimulants and depressants are, of course, addictive and may have serious side effects. So, if one were considering trying them, they should think twice. Now, stimulants increase energy and alertness while suppressing appetite. They are, however, highly addictive. Commonly used stimulants include, on the non-prescription side, caffeine and nicotine. On the prescription medication side, there is ditraxoamphetamine, parentheses, dexedrine Adderall. Oh, Adderall. There you go. Methylphenidate, or Ritalin, or Concerta, or modafinil, parentheses, Provigil, Nuvigil, parentheses. Then finally, on the street drug side, we have 3,4-methylene dioxymethamphetamine, or MDMA, or Molly or ecstasy. Methamphetamine, of course, crystal meth, Walter White, and cocaine. There you go. They are often used, or abused, to boost endurance and productivity. They may also help maintain mental focus, intensify concentration, augment energy, and reduce appetite. They affect the body by increasing blood pressure, temperature, and heart rate, and breathing rates. Some stimulants help breathing by expanding the main airways of the lungs. After frequent usage, users may develop a tolerance to some stimulants and need more to produce the same effect. Doctors usually prescribe stimulants to treat attention deficit hyperactivity disorder and narcolepsy. Narcolepsy, a chronic brain disorder that causes extreme daytime sleepiness. Stimulants are sometimes prescribed for limited short-term use in people with obesity, but only when other therapies have failed. Side effects caused by stimulants include high blood pressure, rapid heart rate, and bleeding into the brain. Another rarely considered side effect is depression, which often results when the effect of this drug wears off. Opposite stimulants on the drug effects graph lie depressants. Depressants are drugs that relieve anxiety and help with sleep, but are also typically highly addictive. Depressants slow down body functions, including heart and breathing rate. Some of the most commonly used depressants include, on the non-prescription side, alcohol. On the prescription side, medications include diazepam, otherwise known as Valium or Diastat, alprazolam, or Xanax, zolpidem, otherwise known as Ambien, Edular, and Intermezzo, or carizoprodol, or Soma, or pentadebretol. There you go. Finally, on the street drug side, flunitrazepam, otherwise known as Rahipnol, or Roofies, or Ruffies, I'm not sure, gamma hydroxybutyrate, or GHB, to say it much more easily. Finally, narcotics are drugs that are similar to depressants in that their main side effects are generally drowsiness and an inability to concentrate. Sorry about that. Legal narcotics include morphine, which is prescribed for extreme pain, and codeine, which is a cough suppressant and a mild painkiller. Another narcotic, hydromorphone, is a synthetic opiate prescribed for severe pain. People requiring these long-term painkillers are highly in danger of becoming addicted to other prescribed narcotics, such as hydrocodone and oxycodone. Illegal narcotics include opium and heroin. Now, to alcohol. The next drug on our list is technically a subcategory of depressants. However, it is so potent and prevalent that it warrants its own section: alcohol. This central nervous system depressant is legal, but it's also very potent. In overdose amounts, it can destroy nerve cells and even kill you if you're not careful with it. Alcohol's effects on the body depend on many factors, such as how quickly alcohol is absorbed into the blood, the amount of food in the stomach, body weight, and individual tolerance to alcohol, which influences how quickly alcohol gets to one's brain. A person not accustomed to drinking may exhibit intoxication after one drink, while someone with a higher tolerance may not exhibit it after 20 drinks, somehow. Of course, all effects of alcohol are increased when it is used with other medications or drugs.
Alcohol. Do not forget that alcohol can cause health problems and be fatal when abused. Our livers metabolize alcohol by changing it to acetaldehyde, and then afterwards into acetic acid. Acetaldehyde, by the way, is toxic and primarily responsible for hangover symptoms. Liver problems are common among alcoholics, whose livers must work harder to convert the acetaldehyde than those of non-alcoholics.
If alcohol is consumed, the level of alcohol circulating in the blood increases, along with its effects on the brain. Someone with a blood alcohol concentration, or BAC, of 0.15% will retain alcohol in his or her body for approximately 10 hours and is not allowed to drive for the majority of that time. The cost of driving while impaired is high, in the respect of both loss of lives and in penalties and legal fees, most importantly. Someone found driving while impaired more than once can lose their driver's license for life and may even end up in jail. Now, the most fun. Anabolic steroids. Anabolic steroids. Anabolic steroids. Anabolic steroids promote cell and tissue growth and division. They have a chemical structure similar to testosterone, the male sex hormone. Steroids were originally, stop laughing, class. Steroids were originally used to treat hypogonadism, a condition in which the testes produce abnormally low levels of testosterone. Today, they are used to treat some cases of delayed puberty, impotence, and muscle wasting caused by HIV. The term doping describes the use of substances, mostly steroids or testosterone, to enhance athletic performance. Doping has been banned by most organized sports because many feel it violates the spirit of competition by providing an advantage to dope participants. However, athletes who dope often suffer the consequences. The negative side effects of anabolic steroids range from the mild ones, such as acne, increased body hair, and baldness, to severe ones like high blood pressure and high cholesterol levels, impaired fertility in males, and blood clotting, kidney and liver cancers, and heart attacks. So I think the downsides are kind of outweigh the upsides. But anyways, mentally, they create mood swings, impaired judgment, hostility, and aggression. All right. This is John Mills and Trace and TJ and Rachel signing off.
If you have a question, leave it in the comment section below. If you have any questions, leave it in the comment section below. Don't forget to like and subscribe and share with your friends. So